So the now is the first step that we are going to use. So it is retrieving the raw reads. How to retrieve the raw reads? So SRA is a database that we use for retrieving all the RNA-seq and DNA-seq data. Sequence read archive data available through the multiple cloud providers and NCBI server is the largest publicly available repository for the high throughput sequences data. ठीक है? So these kind of data that we generated from the sequencing companies like Illumina 454 and others sequencing companies like that. So we need this type of data into a repository. Which kind of repository contain all that data? It is NCBI SRA. So NCBI SRA contain all the sequence read archive data for our high throughput sequencing data. So it's an archive that contain all the sequencing data. So how we can download this data? Simply by using the web interface, you can download that data, but by the command line, you can use the NCBI SRA toolkit. So first we need to download the SRA toolkit. So I'm gonna download the toolkit with you guys, then I'm gonna extract the file, and then I'm gonna append the binaries to our path. After that, we are going to check that our tools that are provided within the NCBI toolkit are working or not. Then we are going to retrieve a FASTQ and then trim it to the tool base pair length, and then we will be moving on. So I'm gonna copy this and paste it into the text file so we don't have to type it again. So here we are. So just moving to the desktop, and here we gonna open our bash terminal. So our bash should have open now. Okay, I'm gonna close my this terminal, and here I contain the three files: FASTQ file, a genome file, and a GTF file of that genome. Don't worry about it, I got these three files already, so if my internet connection is not strong enough, then I don't have to do this all again. So for getting our SRA, I just need to open our and then wget our file that we need. I'm gonna copy this command and paste it here. So here you can see that it is resolving the terminal, and then it is connected to the NCBI archive, and it is downloading the file. So let's just wait while the file is downloading. So 0% have been done. So one thing that we can do is I already got my file in my Unix system. Like here from my lab, I'm just gonna copy this and then close my terminal. Yes. So you know that file is downloading. I'm just gonna paste the SRA file. Now that I have got my SRA file, so just consider I downloaded the file. So I'm just gonna open it and then copy the next command for extracting the SRA file. So here, so it's extracting all the files, and it should. These are all the list of software that are coming within the SRA toolkit. Here we got the folder of SRA. I'm gonna open this folder, and here you can see we have extracted that. Yep, here you can see the SRA toolkit is available. Here is the bin folder that contain all the softwares. So how to use these software? How to use all these software to retrieve the data? So first we have to append to our binary path. So remaining in this folder, I'm gonna append the path, and then I'm gonna see if it's working. So I have appended the path. After appending the path, then I'm gonna check if my FASTQ dump is working as well. So yes, FASTQ dump is working. It is in the folder of bin, which is here. So I'm gonna move to SRA toolkit folder, and here I'm gonna see if my if I can configure some data. If I can configure yes, I can configure my, here I will move to the and save it to the current repository, and then I'm gonna close it and I'm gonna click yes and then OK. So let's test if our FastQ dump is working. So yep, there are 3 counts that are available for this. I'm gonna move to bin folder and see if FastQ dump is available. Yes, FastQ dump is a software that we use to retrieve the SRA reads. So retrieving the reads is done, and I'm gonna move to the back folder as well. SRA section is done. So let's just open our file.fastq. I already trimmed the fastq file because we can do the analysis once again quickly. So here we can see this is the random fastq file that I generated for the Saccharomyces cerevisiae, and that is it for this I think section. Now that we have got our fastq file, let's understand what fastq basically is, what FASTQ file is, or how to use the FASTQ file, and what FASTQ file is. So FASTQ file contain the, I already told you, flow cell, lane, tile coordinates and barcode data from where the sequencing was being done. For example, we got the read record header, and then we got the flow cell ID, then we got the lane, and then we got the tiles which were connected to it, and then we got the tile coordinates as well. So if you can look back, here you can see there are a lot of tiles. 120 tiles contain up to 5 billion reads. So we all reads that have that kind of coordinates here. Barcode is also implemented, and here is the read basis and the read quality scores. So in the next lecture, we will be moving on to the quality score and checking the quality of data, checking the quality of these reads. So that was it for this lecture.